This is Trigonometry, section 5.3. We're going to go through all of the other trig functions pretty briefly. So they have kind of that same idea of the transformations as sine and cosine. So we'll use that same A, B, C, and D for both sine, cosine, secant, and cosecant. The only thing that is slightly different is that the trig and the tangent and the cotangent have a period of pi instead of 2 pi. So the only thing that would be different is for tangent and cotangent, for the period you would take pi divided by b instead of 2 pi divided by b. But all of the same A, B, C, D apply in exactly the same way. So we'll shift, stretch, shrink, flip, all of those things to these shapes right here. In the first couple problems, you'll actually find some values, so hopefully it'll kind of help you make sense of why it forms this crazy shape right here. All of our sines and cosine values were always limited to numbers between +1 and -1 because we were in that unit circle. But you'll notice that these last four right here go, of course, outside of that unit circle. And what it is we're dividing. So we know that when we divide by a decimal, so for example, if I have 1 divided by the decimal of 0.5, well, that's really 1 divided by half is 2. The smaller that decimal gets, so 1/4, 0.25, is 4. The larger the reciprocal is. So that's what's happening here. And right here, these red lines are the asymptotes. So we know that the secant is 1 over cosine. And we know that cosine is 0 at pi halves. So right here, there's an asymptote right here because the secant, 1 over cosine, cannot equal 1 over 0. We can never divide by 0. So all of these last four have lots of asymptotes everywhere that the denominator would have been a 0. So tangent, of course, was sine over cosine. So we see those asymptotes everywhere that the cosine would have been 0. Cotangent is cosine over sine, so we see those asymptotes everywhere the sine would have been 0. Cosecant is 1 over sine, so we see those asymptotes everywhere sine would have been 0. 0, pi, 2 pi. Now the rest of it comes from, like I said, just finding the reciprocal, and the smaller that the original sine was, the higher, closer to infinity, that this right here would go, towards that asymptote. You find that in quadrant 1 and 2, the signs were positive, so the cosecants are positive. In quadrants 3 and 4, the sign was negative, so the cosecants are negative. So all of those same quadrants, everything we've already learned still applies. We just see it in a graph. And it looks a little bit weird, but it kind of helps us make sense of all these things. So like I said, we can shift, we can stretch, we can shrink. The stretch and shrink are a little less visible because it almost kind of looks like a parabola. And so when our parabola gets skinnier, it doesn't show up as much as it did for the frequency of the sine and cosine. But all of the same things happen. Now, the XYZ was kind of limited. It had features to graph these repeating cycles of sine and cosine, but there wasn't a good way for them to create these graphs. So all of these tend to be in the multiple choice format. So you'll just have to be able to recognize what happened in each of these pictures. So looking at these, I have basically one of each transformation. Here's the original tangent. This one was a phase shift. Okay, it moved left and right. This one got stretched. Okay, this one affected the amplitude. Now, like I said, it's a little bit harder to see in these, but basically this was a stretch. It affected the amplitude. This one affected the frequency or the period. Okay, because it was inside, so it made it get squished. And then last, this one was the vertical shift. Okay, so let's see if we can spot these. So even just looking back here at our notes, we know the original tangent should look like this. It's 0 where sine is 0. It has asymptotes where cosine was 0. So the original graph looks like this guy right here. Here's the asymptote at pi halves. Here he is hitting 0 at 0. Okay, so this one is, we'll letter these A, B, C, D. Okay, so this is the original A, just from matching it up to our graph. This one is the most obvious because it is more frequent, so this one's going to be D. This one got bumped up. Notice how it's centered right here. So it almost kind of looks like a cubic. So right here it got shifted up 4, so this one is E. So then the last two, which one do you think got stretched and which one do you think got shifted left and right? Well, obviously all of the rest of these hit 0, 0, except for this guy. So he must have been the phase shift B, and then this one must have affected the amplitude. So even though it wasn't super obvious because this right here is a weird squiggle, this one is obviously a more stretched out, flatter looking squiggle. So this one is C. So you can just kind of narrow it down like that. So all of these, like I said, are multiple choice. You'll just have those first couple where you're finding values just to try to help you understand why it makes this funny shape. So I hope this is helpful. Let me know anytime you have questions.